So in this example, it says determine the midline, amplitude, period, and phase shift of the function. Okay, so we'll talk a little bit more about the midline. The midline is D, and it's going to be the equation y equals D. It's going to be a horizontal line, okay? I don't think I mentioned that earlier, although we did talk about it a little bit. Okay, so for our purposes, you know, we can look at it this way. So we know what D is. D is 1. So the midline, I'm going to write it in green. Y equals 1. That's going to be the midline then. The amplitude, well, that's going to be the absolute value of A. And so our A is 3, so absolute value of 3 is going to be 3. So amplitude so we've got this, and then we've got the amplitude being 3. The period, okay, so period is 2 pi over B. I'm sorry, the absolute value of B. And for us, it's 2 pi. RB is 2, right there. And so that's just going to be pi. Okay, we have 2 over 2, and then those will cancel, and then you'll just have pi. The phase shift. Well, C is equal to 0 in this case. So C over B would be 0 over 2, which is just going to be 0. So there won't be a phase shift here. Okay? So that's how you find the different pieces, the midline, the amplitude, the period, and the phase shift. Now you might be saying, well, I know they're going to want me to graph this at some point. So what does that look like? All right. So let's draw some graph paper here. We'll mark it off at 2 pi. I'm just going to graph one period. Oops, maybe I'll graph 2 periods. Because the period is pi, right? Okay, so that's, hopefully you're thinking, okay, all of this has to happen now. The sine curve that normally would happen within 2 pi is now going to happen just in pi. So since these are still kind of new to us, let me mark off a little bit here. So a normal sine curve, I'm going to go ahead and put some lines in here. A normal sine curve would be like here, and here, and here, and here, and here. I think I draw better when I dot it. But anyway, that would be the normal 1 period sine curve, okay? But now we've got to do it in pi. So it's got to go from here to here, okay? That means I'm going to add in halfway between 0 and pi over 2, which is pi over 4, and then halfway in between over here as well, which would be 3 pi over 4. So it's going to squish together. And then also, I'm going to have to move my midline. Now first let's think about the compression here. So I would have a point here, a point here, a point here, and a point here, and a point here. And so it would look like, that would just be how it compresses. Now if you want to go all the way to 2 pi, you can. You just have to draw some more points. Sometimes they ask you to graph over, where did I mess up? Over 2 pi, or like 2 periods. Just depends on the directions. And it keeps going, you know, in both directions, but sometimes they'll say, okay, graph over 2 periods or something like that. All right. But now it's not really the graph because we have to shift it up 1. So we'd have to take all our points and move them up 1. So that'd be one period right there. Whoops, not quite. Forgot the other point there. And then we could do a second period. If we wanted to, okay? So that's how the graph would go. Okay, there you go. They didn't ask us to graph it. I just thought we should. They asked us for the midline, the amplitude, the period, and the phase shift. And I forgot to put a box around the phase shift. It's a little bit easier when there isn't a phase shift, to be honest. But